Hi everyone, I hope you can hear me already. It's 10 o'clock, let's start. So if you're tweeting about this session or any other session, please use the hashtag CodeGen2021. Let's get started with some real-time data fetching with GraphQL and Blazor. So I'm Michael Stipe. I'm a Microsoft MVP, and I'm one of the authors of the Hot Chocolate GraphQL library for .NET. Today we are exploring, with lots of code, how to build a real-time application with GraphQL and Blazor. With Blazor, Microsoft, for the first time in years, gives us a viable solution for building real-time applications, rich SPA applications that run natively in the browser. But we are not stopping there. We are taking Blazor today to the next level by removing the the friction of data fetching that you have with traditional technologies like gRPC or REST or any other thing like maybe SOAP, by putting the front-end developer in the driver's seat. So before we are getting started, let's just reflect on what GraphQL actually is. I know there are a lot of .NET developers that still maybe don't have an idea what GraphQL is or have the wrong idea what GraphQL is. So GraphQL was originally developed by Facebook back in 2012. It was developed to improve the workflow of interacting with the front end. So essentially, it was GraphQL is optimized for data fetching and puts the front-end developer in the center. So let's have a look at a simple GraphQL query to explore why this is so. So this is a very simple GraphQL query. It essentially asks for the currently logged in user, and from that currently logged in user, just for the name of this user. If you send that to our GraphQL server, we get a response that closely aligns our request. It almost is as if the GraphQL server just filled up our request graph with some data. It is not like that, but it's a good mental picture to start thinking about how GraphQL works. But as our use cases change or we are building out other components, we can just change the request to fit our needs. For instance, we now need to also get the profile picture of our currently logged in user. And again, if we change our request and send it back to the server, we get what we expected, what we asked for. So our request and response again closely align. And if we look at this, we already can see that GraphQL is not only about flat data structures or sparse fields that you have already in REST. It's about trees of data. I can dig into data, dig into relationships. For instance, I can ask for the user and also for the friends of this logged in user. But if we look at this simple request here, we can see already some repetition. Like as we build larger requests, we repeat ourselves, like in this instance, name and last seen is used 2 times. And in GraphQL, we have something called a fragment. A fragment is basically a primitive for composition. It allows us to build fragment hierarchies as we build component hierarchies in our UIs or class hierarchies in our backends. So with GraphQL, we have just one endpoint because the user, the consumer of our service, crafts the requests. So we just need one endpoint, and not like with REST, for instance, where we have a couple of endpoints, since we need to expose all the needs before the need even happened. So GraphQL puts the front-end developer or the consumer of the API in the driver's seat, as I said. And with GraphQL, we can fetch all the data we need at one specific moment in time in one request. And this gets rid of the over or underfetching problem on the client side. Overfetching is always when we have to consume more data than we actually need, because the backend set this request structure is like that. So if you want, for instance, to fetch the user, you also have to fetch the profile picture. With GraphQL, you can decide what you need. And also, we don't have the problem of underfetching, which essentially appears when the request doesn't deliver enough data. And we have to build those flows to fetch the data we actually need. And these consecutive requests that always need the previous request to execute the next one. And GraphQL is built on a strong type system, meaning that you really can trust the data you receive. The execution engine will enforce that a string is a string, or that if you tell your consumer that this is a non-nullable string, that it will never be null. And this makes GraphQL really predictable to use. But we are not doing just GraphQL today. We are putting it into Blazor, and not just any Blazor. We are putting it in Blazor for WebAssembly. And with Blazor for WebAssembly, we are, for the first time in years, able to run .NET in the browser. But not like in the years before with Silverlight. It's not a vendor plugin into our browser. All the major browsers now fully support WebAssembly, and it is an open standard. So with that, we essentially run .NET Core in the browser. And that is really cool, because we can reuse our existing libraries and our existing code that we already have lying around, that we aggregated by building our backend applications and so on. Just a second. My cursor doesn't work anymore. Okay. And that means also that we can use less JavaScript and more .NET. Why less JavaScript? I will explain it a bit. And the very nice thing with Blazor is that we run in near native performance. It's optimized in the browser, and it's fully safe. And WebAssembly, as I said, is an open standard. It's supported by all the major browser platforms, and there's no extra plugin needed. And all of Blazor is open source, so you can head to GitHub, look at the source code, and reason about what they built, or even file an issue. So how does it work? In order to create Blazor UI components, we are using a combination of C# and Blazor syntax. The mono runtime is downloaded to our Blazor app into the browser and enables us to run normal .NET applications. So all of this is running in a WebAssembly VM, so in a sandbox. And you see later when we run our Blazor applications that we have all those assemblies downloading to our browser. This sometimes feels a bit strange, because you're used to having just HTML files, images downloading to your browser, but it's fully safe. It's all sandboxed in our WebAssembly VM. And Blazor essentially has something like a shadow DOM, where we build up in our WebAssembly VM essentially the component tree that we are rendering. The important thing here is that WebAssembly itself cannot update the DOM. And for that, we need some JavaScript. This JavaScript we don't have to care about. It's provided by the Blazor runtime, and it will help us to essentially patch down the updates to our component tree to the actual DOM. And it also works a way back. So every time a user does something, interacts with the DOM, clicks on something in the DOM or writes a text, it will be patched back to our shadow DOM. Okay, so what's the state of Blazor? Can I use it? So Blazor for Server shipped with .NET Core 3.0. It's very stable and now already battle tested. Blazor for WebAssembly was shipped last year in May. It is built on the same Blazor core, and the thing that essentially changed is how we update our DOM, and that we are essentially running now in the browser. But there are more things coming. Blazor for progressive web apps and Electron is in preview with .NET 5. And there are other experiments like Blazor Native. And how flexible Blazor really is, Steve Sanderson showed last year, I think, or was it 2 years ago, when he presented an experiment called Blutter, where essentially he put in a Blazor runtime that renders Flutter components, and Flutter doesn't even run in .NET. It actually uses Dart. Okay, so let's start with some code. This was just to get you a bit into the subject, but I think let's code something because this is one of the live coding sessions. Okay, so when I thought about a cool real-time application example that we could do, I immediately came up with something like Slack. Because Slack is all about real-time data. We have the simple pulls. When we open the app, it just pulls down the actual state of our application or the new messages. If I write a message, I essentially change data, and as other people answer to my messages or write something to a stream, we get all those real-time events. So let's build something like that with Blazor and GraphQL. Let me pull up, let's run. Let me pull up our first demo. Nah, that was not what I wanted. Demo 1. Okay, and this is a simple Blazor application. Let me walk you through it. We already have a point where we can orientate us, and this is the program CS. It essentially is in every .NET application that you can run in .NET Core. It's if you are building a ASP.NET Core web server, you have a program CS. If you're building a console application, you have a program CS. So we know how this thing works. It essentially always has a main method that is our main entry point. As with ASP.NET Core applications, we have in here a builder, a host builder. In this instance, it's called a WebAssembly host builder. Okay, and instead of using middlewares in Blazor, we have components. And I'll walk you through that in a bit. Last but not least, we run our host, and then we essentially can browse our application. Let's just run it to see what it is. So I'm just doing this. And let me pull up Edge here. Just run it, and we can see we have a basic layout here. Left-hand side is the area where we will have our users that we can chat to, and in the mid area we will have our bubbles where we can interact and chat. Okay, so that works essentially. Let me walk you through how the components here actually work. So we have a component app. This is our main component. I can go to here and I can see that my app component is essentially empty. In the app component, we could have something like routing and stuff like that. But in my example, we keep it simple. We just have a main component here. Then we have here these underscore imports, and this just holds all the usings that I need in all my components. Okay, so then we have here our actual main components, and there is a concept in SPA applications about dumb and smart components, or stateful and stateless components. Stateful components is essentially where all the magic happens. They are not really reusable. They pull the data in, and they essentially update all the stateless components. Stateless components are mostly reusable. They don't aggregate their own data. They get data pushed down from the upper components. So essentially, you push data down, and if some of those stateless components want to interact, they throw events that can be caught then in the component tree to do something and interact in the stateful components. So in our example, we have this main component. We will put all the data logic in here. And then we have this people list, which essentially represents the left-hand side, what that we already saw, and has our users. If we go in this list, we can see that the component here is made up of HTML, or actually this is translated to Blazor components. So even these divs. And then we have here another component called person placeholder. That were all the nice placeholders that we already saw there. The placeholder is just made up of simple HTML, so no logic in here. And the actual thing we want to put in first is something like the person item. And for that, we need something called a username and a user last seen date to show something there. OK, so let's build something in. In order to build our components out, we need some models to put in here, and we need to be able to pull some data. And for that, we are using GraphQL. So let me pull up a GraphQL IDE here. This GraphQL IDE is called Banana Cakepop. It's built by our open source project, as well as all the libraries. So with GraphQL, I already showed you that the user is in the driver's seat. That means I can now craft up a request that I need. So essentially, I could start writing a query. I could also first explore the structure of my GraphQL server. So I essentially can click on this little book icon here and then see the schema explorer. I already can see that I have queries, mutations, and subscriptions. Queries is for pulling data. Mutations is for changing data, and subscriptions are real-time events. So let's start with pulling in the data for left-hand side site navigation. So essentially all the users that there are. For this, we can call this people, people field here, and essentially drill into the data. So we're going into nodes. Nodes is actually a structure for pagination. I will not go into that, just accept that there is a nodes layer here. OK, so the nodes essentially returns, you can see that here, nodes returns a list of person. So let me just select all the data that I need for our people list. So essentially, let's grab an ID, maybe a name. Then we maybe need the email, the last seen, and maybe an online status. And just for good measure, let's take an image if there is an image of the user profile picture, maybe. OK, let's fire that request up. We can already see that we get some data here. The order is a bit wrong, so this GraphQL API actually lets me define the order. This is not something that is built into GraphQL. It depends on the API that exposes the GraphQL server that exposes the schema, if the schema exposes such functionality. So in this case, we can just say, OK, give me the list ordered by name, and I'm essentially done. I crafted my request. So there's one more thing. In GraphQL, we have named operations. So we call this operation get people. And then we go back to our client and let's set that up to use Graphql Is. So we essentially crafted our request. Let's go back here and set that thing up. So what are we doing with this request? First, we need to set up GraphQL to run here. So we do .NET GraphQL init. And this works because I already installed a .NET Global tool. These are our Strawberry Shake tools. So I have a command here, .NET GraphQL init. I essentially pass in the URI from my GraphQL server, and then I pass in the name of the client I want to have in .NET. So I call it chat because we are building essentially a chat client here. So what happens is that we download the GraphQL schema here, and against this schema we will compile all the queries we have. So the next thing, sorry if you hear my children in the background, but they are fully awake now. So I'm adding a new file called queries.graphql. And now I can paste essentially my GraphQL query into here. So Strawberry Shake, our GraphQL client here, does not do magic strings. So we compile really everything against our schema to native.NET. Okay, so we can see there's already this generated folder, and I now have here my get people class that I generated, and essentially that is returning people. Like it closely aligns essentially to my request here. This is my response. I get the people, and I could then drill in. I can see I get a read-only list of person, and person exactly has the fields in the exact order I defined here. So I'm in control of my API here. Okay, let's put that to use. So first we go to our person item, and what I said, we are pushing data in. To push data in, we need something called parameters, and these are essentially properties. So I'm putting in here a property called person. I call it the user. Get set, and this is a parameter. Okay, awesome. And now I can use this parameter here to bind my property, my data that I already used here. So essentially, this add makes this the property, and from that property, I need the name. Okay. So this is the first thing. This component is now fully functional. It's, as I said, a stateless, a dumb component. The next thing is that we want to use the data here. We want to put this component into our list. So first, we need also some data to add these components. So I would say we have parameter is loading. Oh, awesome. I already had a snippet for that. So let me just put that in. So I have a is loading indicator here. And the second thing is I have people here. That is the person connection, our paging type. Okay, with these two inputs into this component, I can essentially write my a little if query here. If is loading, just let me put the add here, is loading. Then we will just show these placeholders here. But if we're not loading, and if there are nodes, then we are just iterating over the nodes and adding for each of them a person item to our list. Okay, with that, this component is done. So let's move on to the main component where all the magic happens. So first there is an initialize method. Protected override async on initialize. Well, what is that? Async initialize. There's something wrong with this. Okay, so essentially this initialize method here, just let me put the async task in here. This initialize method is called whenever this component initializes, and we use that to essentially grab the data from the server. So in order to do anything with our server, we need to inject our client. So we are using dependency injection in our component. So we inject the chat client that we just generated, and we call it chat client. Next, we need to push some data into our component, bind some data into our component. So we add some properties here. Essentially, the loading indicator, private is loading. Not the property, but let's use that. This can be private. And we also need the person connection. So we take the person connection here, and these are our persons. Yes. And then we can bind that. So we have the is loading. These are the parameters we exposed. So we say is loading. And then we have the persons. Did we call it person or user? We just check. We call it people. Okay. Let's go back here. We say people. And this is also people. And we bind that to our local field. Okay, so the next thing is let's pull some data in. And for that, we need to use our client. So what we're doing is we just say we have a result, which we fetch with our chat client. And now we just have here a get people async method on there. And that essentially is this this operation, this named operation translates to a C# method. And that is how you essentially build up your own interface between your application and the backend. Okay, so we fetched the data. Let's just ensure that there are no errors, no connection errors, no processing errors. And then we just use that result to assign our property here. So we say result, data, people, and nodes. Oh no, this. Sorry, people. And also I just spotted here's a mistake because we want to be loading whenever our component is created, and then only stop loading when our data is there. Is loading is false. Last, we need to signal our component tree that we are done, that it can update the component. So we say state has changed. And in that instance, our Blazor component tree is updated. So essentially, we are done. We didn't do a lot, but we are done. We just have to define some transport specifics here. So we have to essentially add our client to the dependency injection and also define how we communicate with our server. So let's first add our client. So Blazor uses dependency injection, and we can just say builder services and then add chat client. And this we can do because the code generation also generated all the integrations between the, our dependency injection and the client. So I just can do add chat client here. The next thing we need to set up the HTTP connection. So let's say add HTTP client. And is that actually missing? No. Yes. So I need to put some. Oh no, it should be there. So our HTTP client has to be called chat client, and we need to essentially define what the client is, how the client is configured. So we say client. We add here our client configuration, and essentially we tell the client. Wait, there is something wrong here. doesn't compile correctly, or it doesn't show me IntelliSense. I think it's base UI. You know, let's just steal that from my second demo. Sometimes the IntelliSense from VS Code just sucks with Blazor. So I'm just stealing that, putting it in here, and explaining it. It also might be that I'm missing an yes. I might be missing dependency injection. No, maybe this could be. No. Okay, I'm not missing an import here. So what we essentially did now is we added the HTTP client, and we are using the HTTP client factory here. So it's standard API that we also used in the backend. And we just configured it to use our UI here to our GraphQL backend and put in the bearer token that I already put in here. Okay, with that, our client, our UI should now work. So .NET to run it. And then let's check if it works. Sometimes it doesn't, and it doesn't. Let's just have a look at what the problem is. So what we are pulling up here are the developer tools. And there is something wrong with our initialize. So let's have a look. If it doesn't pan out, because we are a bit tight on timing, we're moving on to the second demo because I already have put it there together. Might be that. Compile. It actually compiles. It might also be my token. That might also be my token. Okay, let's move on to the second demo because the second demo is actually the first demo put together. And just run this and then I show you what it should look like. So I'm running this. It might be my token. So if this breaks also the same way, then it is my token. Yeah, it is my token. Let me just grab a new token and then this should work, hopefully. Okay, let's swap out this token up here and run it. Nope. Yes, it was a token, so sorry for that. But this is actually what the first demo should have shown you. It was not the demo that the demo was broken. My token was already expired. I put it in yesterday night into the demo, so yeah, it ran out. So, but essentially we can just go on from here. We now have our left-hand side with all the data pulled in, and essentially, yeah, we could see this was our query here. We have all the data we needed. And so we did the first part of our demo. It worked, kind of, just a token problem, but essentially it worked. So let's make it more complicated. I talked a lot about real-time data and removing friction from data fetching. Let's see how that works out. And for that, let's head back to essentially where we just left off and put some more stuff in here. So for now, we have here our people list that we essentially push the people in. But in this demo, I already put some events already in here. So when we click on a person, we are signaled here, and also if we send a message. I also have here some components that are at the moment commented out. We are commenting them in a bit, but let's first look at this little detail here. So we have events in Blazor, and that is very cool because we don't have to bother with JavaScript in this instance. So when we go to our person item here, we can essentially define here an event callback, and that allows us to hook in events. So whenever I click on here, and you can see here's an @click on the HTML element, and that translates to a native.NET event in Blazor. Okay, just to hint at that. So let's get back to our GraphQL query. Let me put that back into our GraphQL Ide and move that over. So what we did so far is just fetching the data for the people list. But now we want to do more. We want to, when we click on a person, we essentially want to grab the messages that I had with this person. And I also want to write messages. So I need something to write messages. And last but not least, I want to have an event that pushes me the messages down whenever I write messages with someone. So I talked about the front-end developer or the consuming developer of a GraphQL endpoint is in the driver's seat to define the interface of the server and the client. And that's what we essentially do now. We already have a method here, an operation called an operation GraphQL get people. But now we can go here and essentially say, OK, we need another operation that gets us the messages that I have with the user. So I maybe just pass in the email of the user I have the messages with. So then I can maybe grab that person by email and pass in the email that the variable that I passed in here. And if we closely look at that, this is an operation, and that in C# essentially translates to a method with arguments, so parameters. OK, so I'm passing in this email. I'm grabbing the person. Then I can grab the message that I have with this person. And then I need some data from that person, maybe the ID from the message, the text, the direction in which this is an outgoing or an incoming message. I maybe want the recipient and the sender and the send date. But wait, this is a problem. This is a person here. I have a person here, and essentially what I want is to put these three in here, and that is a participant for me. And I want to do the same for sender. So this is the shape for a message participant. So what we can do in GraphQL is introducing something called fragment. And fragment we could call participant, and it is applied on a person. And as said, these are our essentially our primitives for composition. So I can just put in here the fields that we want, and then I could just refer to the fragment that I want to use in this place. But I'm not stopping here. So I then could say, OK, essentially, this is also participant. But actually, this altogether is a person in my universe. So let's define a person for our client. We call it person. On person. OK, now we have to hurry up. Time is running out. And then I'm using the person up here. It will make sense in a second. But essentially, this is the message in my universe. So we can also just describe the message, and we apply this message shape essentially on our message type in the backend. Now I'm just grabbing these guys and putting them here and just refer to the message here. Okay, so with that, we already have a working API again. It hasn't actually changed. If I execute people, it returns the same data. Just before we go on, let me just put an order in here. I always forget that. And we want to order it by the send date. So we have a nice ordered message stream. So the next thing that we want to put in is something to write a message in. I said to change the state on the server, we need a mutation. So we call that send messages, send message. This also gets the email in, and it maybe gets the text in that we want to write. And then we use the send message mutation, and we essentially pass in the recipient email here and the text. Okay. And we can see that the mutation returns a message, a recipient, and a sender. So important in GraphQL, only the top level of this request is actually the mutation. Everything beneath that is, so there are no nested mutations in GraphQL. So this is the mutation. Everything beneath that is the changed state of the server. So this applies a change, the state change in our backend, and all what we can do with the below fields, the message, for instance, is essentially reading the new message or reading the changed data. So this allows us to just grab the message that we produced. So I have now here all the messages. I use the message shape, and I'm producing the message here. Okay. So last but not least, let's put in some real-time magic. And real-time is the same thing in GraphQL from a query perspective than mutation or a query. So I essentially, instead of starting with mutation or query, I'm just writing subscription. And I could call that read messages. And then I can pick from my subscription. So I want to grab messages when I receive them, so on message receive. And I can see that this event actually yields again a message. So I again can use my message shape here. And we also can rename that. I don't want this field in my result type to be called on message receive. I maybe want to be called message, like here, so that this aligns in my types. Okay, so with this, I essentially just defined my whole interface between the server and my client. So let's copy that over and see what it translates into. I'm building, it's generating type. In this preview, it needs to sometimes have two compiles. The release is coming out at the end of this month, and it brings some awesome new features with it and also fixes that issue. Okay, so we now generated our code here. We can see that there is an iMessage now. And what we can see that there is an iParticipant here. So far, so good. If we look at the person, we can see that person implements iParticipant. And this is because essentially person uses participant. So with fragments, I can not only define the data I want to fetch, but also the models I generate in C#. So I can produce proper inherent structures, like that my interface implemented the right interface here. And I can then use the person everywhere where I maybe demand a participant in my components. And this really lets me craft my data structure in a way that it's useful to use in my components. Okay, let's put in these commented out components and then put everything together that we just did. Okay, we have still 50 more minutes. That should be enough. to make this a really awesome demo. Okay, so I put in the components. Let's compile that, and I'll walk you through that while it compiles. We now have a message list that is essentially the center piece of our client. In that, we have a chat message. A chat message essentially gets in a message and a participant, that's the sender. And also it uses the direction to show the bubble there or there. And then we have a footer where we have the message, the text field where we essentially can type in our message. We have the header where we have some additional information about the participant, which in this case is a person, but I can use them however I want. If I pass a person down, it doesn't matter. It doesn't matter because it's compatible with participant. Okay, so let's put that together. So first, let's put in the first part. When we click on a person or a user on the left-hand side, we want to essentially load all the messages that we have there. So we want to just recognize that we have this person. So we put a person, recipient here. And we also want to store the messages that we have with this person. So we take an immutable list of iMessage here. And these are the messages. And in the beginning, we just have an empty list. Okay. So when we grab this person, so we click on that person, we essentially can copy this bit. So we take our chat client, then we say just get messages. We pass in the person email. Our client fetches the data, and then we assign the recipient. Maybe that's the person, and we also create the messages, which is an immutable list.createRange. And we essentially pass in from our result the messages that we just fetched. Okay, and these warnings here are actually nullability warnings. I could say, okay, when I actually check that my result has no errors, it will always have data. This one doesn't matter. So actually all the nullability information that we have in GraphQL we can use here. But this is something doesn't match the target. Okay, I don't care. Messages, that's the error. Okay, let's compile that. Works. So then we just hit state has changed again. And it will work. So last but not least, we need to put in our message list up here. I think I have that as a snippet. So I put in the message list. It essentially gets the loading indicator, the recipient, and the messages that we have here. And then we have this on-click send, which triggers down here. So when we send a message, so this is loading the messages, and when we want to send a message, we essentially can again grab our client here. We just use now a send message. We can use a recipient email because we want to write to that person. We just pass in the message that we get from our component, ensure there are no errors. And now we just grab from our result the message that we returned. I showed you that before. We are returning here the message. There we are returning the message. So we are taking that message here, data, send message, returning it, then updating our state has changed event, and again done. So last, we need to put in some real-time data fetching. So let's look if I have. No, I don't have. So let's just put a little method here to fetch our real-time data. It's essentially very simple. We put a simple method in here, begin receive messages. And because it's asynchronous, we want to just get the data, read the data while it's coming in. In GraphQL, this is done to an async iterator. This translates in .NET to an async enumerable. So we just do a async. Oh, sorry.
I didn't get
Siri didn't get that. Okay, so we run that. So what we want to do here is essentially the same thing again. Let's just grab that. In this case, we say on or receive, read messages, we call that guy. We don't need to pass anything in. And this guy now is a response stream. So we can do an async and a wait for each over that. Oh, let me just check if I have a snippet because time is running out. Let's just use that. Yeah. OK, so essentially that is we wait for each over the message stream and we're adding the messages to our message list. So this guy we just start here at the beginning when our components initialize. And now our thing should work. Let's .NET run that. We have 9 minutes to prove that this works or find any issues. OK, it's up. Let's refresh that. Hope that it works. It doesn't, because I always forget to put in the using here, because this component is in a different namespace. I usually would put the using actually in the imports here, but you know, we don't have so much time anymore. Let's refresh that. Yeah, I can already see we have now here the component. I can go on a user here or this one and see the messages that I have with this user. I can write a new message, hello. And now you can help me debug the real-time events. So there is this link. Let me just undock that. There's this link. Go on there. And then help me debug that. If you go on that link, you get a little Blazor application, that is this guy here, that lets you pass in messages. Let's try that. Hello world. And I can already see my my messages coming in here. So the real-time data works. If you get a chance to do it, would be cool. If not, then maybe the delay is too large. But you can see it works. The backend is in, there's audience. Awesome. So you can see the real-time data is coming in. It's very simple to do with GraphQL since we essentially just wrote, there's the next event coming in. Awesome. Because we essentially just wrote GraphQL and it was no different from anything else here. So it was the same as a query. There's still some things that you have to think about when scaling a GraphQL server with sockets, and also what to do when a socket fails, how to reconnect. But apart from that, it's very simple to write your interface here because you're just using GraphQL and it translates to .NET code. Let me get back to my slides. And then we can. Okay. Okay, you survived a lot of code with GraphQL and Blazor. What is the takeaway here? So with GraphQL and Blazor together, you can iterate much faster. Why is that? Because I'm a .NET engineer and I'm very good at .NET, or I'm sufficiently good at .NET, but I'm not so good at JavaScript. With the ability to just write my front end in .NET that run natively in the browser, not just those old backend applications that have all those communications and all those server turnarounds. I just can write a native application that runs in the browser without any plugins. And by using Blazor, by using GraphQL, I also can iterate very fast. I don't have to go to my backend engineer and always ask him or her for a new specialized function request that I can then use in my front end. I just can craft it. So it's very easy to iterate here. And I can reuse all the knowledge that I gained in my years as a backend engineer. And yeah, we also have all the benefits from GraphQL, like fetching data much more efficient, because all the requests that I crafted are handmade for my use case. I'm just fetching the data I need and not anything more. Okay, if you like what you saw, you can visit us on GitHub. It's github.com/chillicream. You can also sign on to Twitter. It's at chili_cream. Everything you saw is open source. We also have the open source GraphQL server Hot Chocolate in .NET. So we have Hot Chocolate in the back end, a hot drink, and Strawberry Shake in the front end. Essentially our code drink. So join us on GitHub and give us a star if you like us, or talk to us over Twitter. It was nice for being here, so I hope you had fun. And with that, I'm giving back to the conference guys.